Hello and welcome to this tutorial on topic drafting. I would like to show how you can derive a standard compliant drawing from this part. So first let's take a closer look to the task. You have to create a fully dimensioned drawing of these buffer workpiece, and there are given some instruction and hints below. Okay, you have download part files and a 3 drawing template from Moodle, and you have to use scale 1:1 for creating the views, and you have to provide 3 orthogonal views and an isometric view. The hidden lines you have to show where it is useful. You have to add center lines and center marks, but not so in the isometric view. Then after it, add dimensions, arrange them properly and completely, and you can use both single or also ordinate dimensions. And in the end you have to set a tolerance for this hole here and for the thickness of the base body, so this thickness. To make it clear, I want to show first the expected drawing. So let me switch. And you see I created 3 standard views, starting here with the front view, and you always select the most meaning view of a workpiece as a front view. So the front shows my workpiece in this direction here, and then in addition it should be shown in the manufacturing situation. For example, a shaft is shown in a horizontal position because it is a turned part. So here it's fine to show it in this way, and beside on the right side I show the side view from the left. That's the meaning of first angle projection. So what you see here in the side view is what you can see when you're looking from the left side, and you have to project it on the right side of the front view. Yeah, and finally the last one, it's a top view where you can see all the things when you have a look here from top on these part. Here beside the isometric view, in this way shown as a shaded one, all dimensions or most of the dimensions are given here in the front view, and some more dimensions which are not possible to give in the front are shown here in the side view or in the top view. The title block here is completely filled, and there are given some additional informations, for example for the surface roughness here beside. Now I want to switch to SolidWorks to show how I created this drawing. Here we are, and you see I open my workpiece, this buffer part, and as next step I want to open here this drawing template. Here we have to take a 3 drawing template. I pick here and I open it. The university drawing templates contain all standard settings such as line style, line font, or also important the type of projection, which is also shown with this side here in the title block. And it's set on projection type 1 as standard. And you have to generate as many views, including sectional or detail views, to be able to clearly display and dimension the part. And you must avoid double dimensions. So therefore, when you go to the View Layout tab, you see there are two possibilities to start with. You can directly create 3 standard views, or you can start with creating a model view. Mostly it makes no sense to start directly with 3 standard views, because it depends on your workpiece itself. Sometimes it's enough to create only one view and, for example, an additional section view. So I like to start with model view, so with this command I'm free to do it by myself. So pick model view. You see the property manager of this command open here on the left side. And first you have to select part, or also possible an assembly from which to create the view, then click next. Okay, so here you see I have opened a lot of parts, but the one we want to create a drawing from is this buffer part. It's selected here. If you don't open it before, then browse for it. There's a possibility to do so. And then you have two possibilities. You can go further on with a double click on the part you want to use, or you can also pick here to go to the next step. Read this message. You have to select a name view from the list below. That's the list of the standard views. And then you have to place the view here on your drawing sheet. You see there's still one selected. This is the activated one. It's the front view. It's very helpful to activate this preview box. I did so. And there are more possibilities of options you can set in this property manager. For example, very helpful is to select directly a display style, so you can do it, for example, with hidden lines or without hidden lines. You can do in a shaded way with or without edges. I use this one in the expected drawing for the isometric view, for example. When you scroll down, you see there's also possibility to set the scale. Here it's fixed with use sheet scale, but when you activate this option, use custom scale, you're free to use your own scale. For example, I will do a little bit smaller in scale 1:2 and have a look for the preview. So here it seems too small, so I change back to 1:1, or activate use sheet scale. That's the same. Now I start with the front and I arrange it here in this area. And from this front view, I'm able to create other views in orthogonal direction. You see, because standard setting is that you have to do it in first angle projection. When I move with my pointer to the right side, it shows automatically the side view from the left. So that's fine so far. I will place it here, and directly also top view. So when I move with the pointer down, I can place my top view here. And an isometric view, yeah, it depends in which direction you move with your pointer. Please have a look for the different which isometric view will be shown here. Yeah, I select the one which shows me most details of my part. So I like to do it here in this way, because here I'm able to see the front of these, let me call nose, how it's looking in this way. So I place it here. Okay, and that's all. I arrange the isometric view in this way, and you see by clicking on it I can change some options for this view. For example, when you change into hidden lines removed, it's looking like this, or in my expected drawing you saw before, I show it with shaded with edges, but here in this case I will show it in this way. Okay, that's fine. Here in the side view I will add a section view or a broken out section to be able for given the dimensions for this hole in a comfortable way. So therefore I go to the View Layout tab, click on Broken Out section, now I have to define the area for this broken out section with a spline around it. To close it here, and here in the property manager I have to give the depth for this broken out section. I want to do it exactly until your center of this hole. So therefore I click here on outer surface, I activate the preview, and it seems to be fine. Okay, and you see also here in the front view or in all others view in which area you created these broken out section. So it's exactly in center, so I will confirm it here. So in the next step I will add the center lines, center marks and symmetry lines and so on. You see here in the front view this center mark is automatically set, but how can we set the others? Therefore I switch to the annotation tab, and here on the right side I have the possibility here to select center mark command or here the center line command. Okay, first I want to set a center line here in this area of the through hole, then a second one here in front of these, let me call nose, and you also have the possibility to arrange it a little bit nicer. So when you click on this you see the two handles on the left and on the right side, and here you are able to move it a little bit more to the left side. And please arrange the center lines only in a way that it's maybe 2 or 3 millimeters longer at the outer shape of your part. So don't do it in this way, it makes no sense. That's the way which is okay to do. Some more lines we have to add in the front view. Therefore I select this edge and the one here on bottom. I arrange directly the center line in a, maybe that's enough, fine way, because there's only symmetry in this area here. So I take also this handle, put it a little bit more outside. That's fine. the center mark is already done, so I change to the top view. Have a look what we can do here. That's clear, we have also added a center line between these two lines because this gives the position of the through hole here in the top view. I confirm here, and then I like to start with giving dimensions. Therefore you see here on left side of the annotation tab there's a button with smart dimensions. When you open it here, these fly out, you see there are a lot of other options. I want to start with smart dimensions, and a little bit later I also want to explain how you work with these ordinate dimensions, which also possible here in this case. So let me start with smart dimension. I start with the front view, and I want to do it related on this edge and on this edge on the right side. So I start here by picking this edge, and the first distance here should be distance to this middle part here of these nose beside. That's the first dimension, and then I do it step by step. I want to give a new one to this edge here, to this corner, then to the center of my hole, and the last one in this direction should be the complete height of this part with 120. So you see, this is the way you do it with a smart dimension. Now I want to show the option of ordinate dimension. Therefore you have to pick first a baseline from where you want to start with it. You see, when you move down, it's named with O, and then I only have to take the next edge which I want to dimension. For example, here the distance is 20, and of this part on the left side it's 63. So that's also possibility to do, but I like to do here in only one way. So I will make this last command undo by picking here 1, 2 and 1 time more, and again I take only smart dimension, start here on this right edge, pick this point, arrange the dimension again from here to the left, and arrange it here. The standard distance between the dimension lines here is already set in the document properties, so that's the first dimension here. Have a look here for these 20, for example. Snap 10 millimeter, and each further dimension line 7 millimeters from each other. Okay, but I have to do something more. Here on the left side I want to add the length here with 6, and the distance or the height for these nose with 40. And then there is one more dimension missing. I need also this angle here, and this one should be 10 degrees. Okay, that's fine. Maybe here on upper portion of this front view we can add the distance from here to center of the hole with 25, and the complete width, okay, with 50. So, and now I want to have more distance between front and side view, so therefore I arrange this view a little bit more to the right side. And now I start also here with dimensioning. Again, smart dimension. I want to give information about the diameter of this hole here in my section view. It's 25. And in the task there is a hint that you have to set a tolerance for this hole, and you can see here in the property manager beside you have the possibility to edit the dimension text. Therefore I position my cursor here and add, for example, age 7. It appears directly beside diameter 25, and I will confirm it here. Or better is to do directly the next one. So there's a chamfer on the left and on the right side of this hole. So I pick this edge and the next one. Sorry. Here. And you see it's 1, but I want to give 1 time 45 degrees. So again here I position my cursor in this way and write 1 times 45, and the sign for the degree, you will find some basic signs here below. I pick the degree sign and it appears directly here. I can also arrange it a little bit more proper. That's fine. And some information more about the dimension, I have to give here in the top view. Here on the left side I have to give information about first maybe the angle of this oblique line with 2 degrees, and then the distance from the line here in the bottom to the edge, this one, 34, and the complete distance from here to here with 40 millimeters. Seems to be fine. Okay, I will arrange this 2 degrees a little bit more outside. And the distance from here to here also missing. And here again, like it is forced in the task, I want to add tolerance for the thickness of base. Here you see in the options I have the possibility to set different options. In this case I want to do it bilateral, and there is a maximum variation I will fix with 0.1 and the minimum one with, for example, 0.2. Okay, and it appears directly here beside, but I'm not so happy with the font, so I want to change it, and therefore I have the possibility to change here from the value card to the other. And you see here I have the possibility to change the different fonts. The first one is a text font, it's 28. That's nice. I want to leave it in this way, but I want to change the font for the tolerance size. Therefore I deactivate this box here, and here I can use dimension size. I want to deactivate it also, and now I'm free to change it. I want to give directly a font height here. Okay, you see there is 12.7, that's much too large. Let us change to 2.5 for example, and you will see the result. Okay, that's better, but a little bit smaller should be also fine, so I will take 2, then it's 0.1 and minus 0.2. But one thing more, I change back to value, and here I can also change the number of digits behind. So I will do it only with 1 digit. Okay, now I have to change again the size here, 2 mm, and now it's fine so far. That's a way you can give a tolerance behind a dimension. So, and I think with this last one, the dimensions are ready so far. Complete drawing. And one hint more, it's really important that you avoid double dimensions. So, but here it seems to be fine. Here in the side view, I want to show how you can change hatching, the hatching for this part. Therefore you have to click on or in this area. You see the broken out section, a property manager appears, and here you can remove these hook in front of material crosshatch, and then you are free to define by yourself. I want to do it, for example, according to ISO steel. That's a difference you see, and the same for the upper part, for the lower part. Again, deactivate this box and select ISO steel, and then it's done so far. Okay, we can also add information about the surface roughness. You find this command in the annotation tab. Here, surface finish selected, and here you can fix all the options, how it looks like. I want to do it machining required, and I want to give here information that all surfaces should have a surface roughness of, for example, 25. The symbol hangs on the cursor and you can arrange it in your drawing. I will arrange it here beside the title block. I confirm, and for the last step you have to fill in the title block itself. Therefore, click on with double click on these fields to activate it, and here you are able to give information, in this case about the name of your part. It's called buffer, or the scale, it's 1 by 1. And all other informations, like you can see here, this is automatically generated. That's a name of the designer. The date is also generated automatically. You have to give informations for the general tolerances, which class you have to take. So I will do it middle, small m. So that's fine. The rest you can do by yourself. And here beside, in the standard template, you see also a description how you have to fill in the other fields you see beside. Fields like a drawing number, or drawing number here, or reference example, and so on. So okay, I see there is something here there's a second surface symbol. I will delete it. That's not fine. But now it seems to be fine. So that's all for task drafting number 3, the buffer. Thanks for your attention.